the next thing that we want to look at is how to test the significance of the correlation coefficient. So I'm going to show you this with an example. All right, so we have a data set given to us, and we're told to test the significance of the correlation coefficient at alpha is equal to 0.05. So I'm going to go ahead and note that the correlation coefficient for this problem, if I were to calculate it, that correlation coefficient is equal to 0.77. And you could easily check that if you wanted to. You're welcome to pause the video and type these numbers into your calculator and let your calculator calculate that R value to see that that correlation coefficient is 0.77. Now, what we want to do is we want to look specifically at how to interpret that. So we know that the correlation coefficient can be any value between -1 and +1. And we know that if the correlation coefficient approaches 0, it has a specific meaning as well. So my question to you here is that this 0.77 is falling between 0 and 1. And so I have to determine if 0.77 is close enough to +1 that I can conclude that there is a positive linear relationship between the variables. So that essentially is the question that we're looking at here with this. And I'm just going to sort of jot this down so that you know where we're going. So we want to know, is 0.77 close enough to +1 to conclude that a positive linear relationship exists between the variables. Now, obviously, 0.77 is closer to +1 than it is to 0, but without doing some statistical work, we can't be sure that it's close enough to make that conclusion. Okay, so I'm going to go ahead and clear the screen, and we're going to talk about how we go about doing this test to see if the 0.77 is close enough to +1 to make the conclusion that we want. So we're going to talk about a 5-step process. It is a form of what we call hypothesis testing. Step 1 in this process is going to be to write down 2 hypotheses. And for this step, this is fairly easy because this is always the same regardless of what problem you're working. So you're going to have what is called a null hypothesis. And we're going to denote this by H0. So that's going to be one of your hypotheses. And that statement is going to look like this. All right, so let me do a little bit of explanation here. The P is actually the Greek letter rho. That is the symbol that we use for the correlation coefficient of the population. So it's the same as the R that we've been using for the correlation coefficient of the sample. All right, so I'm just going to kind of make that note so you'll have it in your notes that this is the correlation coefficient for the population. All right, and so our null hypothesis, which is the H0, is saying that that correlation coefficient is equal to 0. So what does it mean about a relationship if our correlation coefficient is equal to 0? That means that there is no relationship. Okay, so our second hypothesis, and again, remember that we're going to have 2, is what we call the alternate hypothesis. It's going to be H1, and it is always going to look like this, which basically says that the correlation coefficient is not equal to 0. And if it's not equal to 0, then that means that there is some sort of relationship existing between the two variables. And that's really the only two possibilities that we have. So this is basically saying either the 0.77 is equal to 0, in which case there's no relationship, or it's not equal to 0, in which case it's close enough to +1 to conclude that there is a relationship. Okay, but as I said, step 1 is always going to be the same regardless of what problem you're working. All right, so let's move on to step 2. Okay, so for step 2, what we're going to do is we're going to go to a table in the back of your book, and I will post it in the content section as well. This is going to be table I. And on that table, we're going to find the critical values. So go ahead and take your table. I'm just going to talk you through really quickly how to find this value. It's fairly easy. The thing that you need to know is that on this table that the DF is going to be your sample size minus 2. All right, so that's a little bit different than what we have used before for DF. Remember that when we were looking at table F, or when we look at table F, which we'll do in which we did back in chapter 7, we used as our DF, we did the sample size minus 1. So now we're going to do the sample size minus 2. So you just want to remember that if you're testing for significance of the correlation coefficient, it's going to be sample size minus 2. All right, so in our particular problem, how many data values do we have? So remember that this is a data value, and this is another one, and this is another one. So we have, and I'm just going to kind of count them here, 1, 2, 3, 4, 5, 6, 7, 8 data values. So our DF is going to be 8 minus 2, which is equal to 6. And then the other thing that we need is the alpha value. So remember in the problem it told me to use alpha being 0.05. All right, so if you'll take those two pieces of information and look that up in your table, go down to the 6 on the left-hand side and then use the 0.05 column, you'll see that we're at 0.707. Okay, and this is going to be our critical value. And that takes care of step 2. All right, so now for step 3, what we're going to do is we're going to draw ourselves a number line. And we're going to mark off this critical value both in the positive and in the negative sense. So I'm going to mark off a negative 7.07 and a positive 0.707. And then also on that number line, we are going to mark off the correlation coefficient that we found when we worked the problem. Remember that that correlation coefficient, that R value for this problem, was 0.77. So I'm going to come over here and mark off 0.77, and it's positive and it's bigger than 707, so I'm going to put it over here. Okay, and that takes care of step 3. All right, step 4 talks about how you're going to interpret this. So if your R value is either larger than your critical value on the positive side or smaller than your critical value on the negative side, you are going to, what we say, reject the null. Okay, so the easiest way to remember this, and they'll do this in the book as well, is to sort of shade in this section here. and shade in this section over here, and above it write down the word reject. So if when you mark off that 0.77, if it lands in either of those two shaded green sections, our answer on step 4 is going to be to reject the null. All right, so we're coming back over here to our null hypothesis, and we're saying no to that hypothesis. That is our null hypothesis, and we're going to go with the other one. So step 5 is your conclusion. And so for step 5, you're simply going to take the conclusion on the other one, which is there is a relationship. Okay, now what that tells me, again now, is it tells me that the R value was close enough to +1 to conclude positive linear. Okay, it also tells me that as I move into the next section, we're going to be talking about finding the equation of a regression line and doing what's called a regression analysis. So if there is a relationship, we want to continue with that regression analysis that's coming in our next section.